Okay, so I write down the problem to begin with. Now this problem can be solved in more than one way. I'm just using the quotient rule to illustrate. It's not necessarily the best, but it's not a bad way to do it. Well, I have to be honest, in this case, there's a much faster way than the quotient rule, so we're going to use the faster way. If I remember a property of exponents, I can remember that what I see here is really this. D over dx of negative 1 over 1 multiplied by 1 over e to the negative x. You do not have to write that step if you can do it in your head. I'm simply writing it so no one gets lost. Questions? Cool. Now remember the property of exponents, which says that I have this now. We're going to write y prime of x here so you get used to the idea that that's legal. So I'm going to have d dx. I haven't done any calculus yet. Other than, oh look, this is a constant multiplied by a function. So that means I can move the constant out of the d dx. So I can put the negative 1 right there. Questions? Then I remember 1 over e to the negative x is actually e to the positive x. Like that. Please, Darren.
Why did you put the negative 1 in front of the thing instead of just the regular, like 1? Because like the 1 on the bottom that you bracketed or whatever, that says on a negative, right?
Oh, 4 points for Zaren.
Oh, wait. Sorry.
You see it now? No, you're not. Do you see it though?
Yes.
No worries. Yeah, that fraction is really just negative 1. I just put the 1 on the bottom to make sure we didn't lose track that we really have a fraction here multiplied by another fraction. No, it's a good question, Zaren. 4 points. Anybody else? Memorizing the E rule is really easy. The derivative of e to the something is just e to the something multiplied by the derivative of the something. So this becomes negative 1 e to the something derivative of the something, which is just 1. So the final answer is negative 1 e to the x. This is an example, like I was saying to Jake, 2 more points for Jake, where such a simple problem can lead to so many wrong answers. Yeah, the negative just causes all kinds of trouble. So, please.
Is your answer equal to your first question, or because isn't negative 1 dx the same as? So would it just keep when you find derivative, would it just keep it the same?
4 points for Jonathan. In this case, this is a interesting function in that you would use this formula to find every x-y pair of the function, and you actually use the exact same formula to find the slope at every xy pair. So you get a graph, and I don't remember exactly, well, wait a minute, negative 1 e to the x, that's going to look like this. Let's see. Come on, brain. Like this. Every single y coordinate on that graph, every single y coordinate on this graph is not only the y coordinate, it's also the slope at that same point, which is not super common, but it is a characteristic of E. Like e to the x has that general property. Another one that does that is this one. Y equal e to the x, same thing. dy dx is just e to the x. We don't take time in this class to investigate the y of that. Just can't investigate every y. And so I actually don't know that off the top of my head why that happens. I just know it does. So 4 points. Anybody else? Please.
On the quotient rule, it says it's over d squared, but when you use the quotient rule, it says wait, did you use the...
I didn't, so I kind of got a little off track there, David. 4 points. I was thinking of showing you an example of using the quotient rule and then I couldn't bring myself to do it.
Because I was like, wait a second,
Yeah.
that's not the quotient.
It was too easy to not use the quotient rule. So I just, I couldn't bear to use it. So I meant to.
Did you just use the multiplying constant on the over?
So what I did, so from here to here, is just same first step as always. I'm just finding the derivative. So I'm applying the ddx operator to both sides of the equation. The next step is not calculus. The next step, I just wrote the two factors separately, which I do a lot, because it makes it easier to see what we're talking about. So all I did was say, oh, it's really just -1 multiplied by 1 over e to the negative x. I just separate them to make it easier to think about. The next step isn't calculus either. Now I'm just using a property of algebra that tells me that this is the same as this. Remember, right here, most important thing to understand in the entire class. Like, how do I properly use equal? And you just keep using it over and over again. These two purple things are equivalent per a rule that you learned in algebra, okay, previous class. The next line is calculus. Now I'm using the E rule. And that's it. More for David. Question? Oh, please, David.
I'm not complicated, but could you do this problem for us with the quotient rule so that we know how to use the quotient rule?
Let's do a different one, just so we have more than one. Is that okay?
Yeah.
More than one example. So let's stop this video.